Hello people, let's watch this video together. Wow, magic! Okay, let's see whether we understand what has happened so far. So obviously the light from the bear is an unpolarized light. After we have added the first polarizer, what we did is the light hitting our eyes now is polarized. So obviously these two polarizers are polarized perpendicularly to each other. As a result, the vertically polarized light after passing through the first filter cannot pass through the second filter, which is polarized horizontally. That's why the bear disappears. So we understand what is happening so far, yeah? Okay, let's carry on. By adding a third filter, the bear reappears. Does that surprise you? If it does, try to think through yourself what's happening before I explain to you what's happening. So we start with the unpolarized light from the bear. We pass it through the first filter and get light which is polarized vertically. With the second filter, which is polarized horizontally, nothing passes through and therefore the bear disappears. This part is easy, yeah? Now you have to realize that the third filter that was inserted between the first two. And the third filter is polarized at an angle to the vertical. So what happens to the vertically polarized light when it passes through the third filter? Well, according to Maser's law, its intensity will drop according to this formula here. So before this filter, its intensity was I0. After the filter, it becomes I0 cosine squared theta. Theta because that's the angle of misalignment between the light wave and the polarizer. Now this light wave is going to be passed through the horizontally polarized polarizer. According to Maser's law, its intensity will drop further according to this formula. So before passing through this filter, the intensity was I1, right? So after passing through it, it will become I1 cosine squared 90 degrees minus theta. What is this angle doing here? Because that's the angle of misalignment, right? Between the light wave's polarizing angle and the polarizer's angle. So you can follow up with the math, then using the complementary property of cosine and sine, and using the identity that sine 2 theta is 2 sine theta cosine theta, we arrive at this expression. So surprise! The final intensity is not 0. Because sine squared 2 theta need not be 0, right? We can plot the results in a graph. So the final intensity is 0 only if you insert the third polarizer at horizontally or vertically, yeah? So it's still 0 if it's inserted with an angle of polarization of 0, 90, 180 and so on. But at other angles, we have a bit of light passing through. And in fact, if you insert the third polarizer at 45 degrees, 135 degrees, 225 degrees and so on, you can get the maximum intensity of I0 over 4. So the key to understanding this surprising results, if it surprised you, yeah, is that a polarizer does more than filtering. When a light passes through a polarizer, not only is its intensity chopped down according to Maser's law, it also has a new polarizing angle. So with this new polarizing angle, it avoids being completely chopped off by the final polarizer. Get it? Okay, ta-ta!